Hello, so today we will be solving third question from weekly contest 442. So the question says that we will be given two arrays, skill and mana. For now, let's say this mana is some operation and skill is the array of size n, and we are given n wizards. So there are n wizards and skill associated with each of them is present in skill of I. Now we have to find the minimum time it takes to complete the whole operation or the total number of tasks. So the time required to complete ith operation, jth operation for the ith wizard is skill of I into mana of j. Now let's see how we. Now there's one more condition that as soon as one wizard completes its execution for some task x, let's say ith wizard completes its execution for some task x, then I plus 1th wizard has to start its execution at time x only. I plus 1th wizard has to starts its execution at time x only. It completed its execution at x, then I plus 1 has to start at time x only. So these are the conditions. When we will be starting with the first task, that is this task, we can start it at time 0 only because this is the earliest we could start. So we start with the task 0 and it will take 5 into 1 for the wizard 0, 5 into 5 for the wizard 1, 5 into 2 for the wizard 2, and 5 into 4 for the wizard 3. So total time is sum of 5 plus 30 plus 10 plus 20. Okay, 5 plus 25 plus 20 plus which is equals to 60. Now when we are executing our first task, we know that we have to start it at time x such that we will be able to execute all our tasks. We will be able to execute the first task for all the wizards if we start at time x and we don't have to wait. Now what is the earliest time we can start executing task 1 for the wizard 0? We can't start before 5 because we were executing first task only up to 5. So how much time does it take to complete task 1 for the wizard 0, which is 1 into 1, which is 1. So we started at 5 and then we started at 5 and it took us 1 unit of time to complete it. So 5 plus 1 is equals to 6. So we were able to complete execution of task 1 for the wizard 0 at time 6. Now we have to start with execution of first task for the wizard 1. Now we can't start before 6 and at the same time we can't start before 5 plus 20. Let's just write here 30 and here 40 here and 60 only. Okay. Now we were able to complete our task at time 0. Now we won't be able to start before 6 because we were executing task 1 for the 0th wizard, and we won't be able to start before 30 because we were executing task 0, operation 0. So it would take us max of 30,6 plus 1 into 5, which is max of 30,6 plus 5, which is 35. Now we move to the wizard 2 and we have to perform operation 1. So we can't start before 35 because we were executing task 1 for the wizard 1 and we won't be able to start before 40 because we were executing task 2 task 0 for the wizard 2. So the earliest we would be able to complete this task is 40 plus 30 max of 40 by 40 comma 35 plus the time it take to complete this task is 2, so it would be 42. Now for executing task 1 for the wizard 3, we won't be able to start before 60 and max of 60 comma 42, which is 60, and time it takes to complete this operation is 4, so 60 max of 40 comma 62 plus 4, which is 64. Now we calculated the earliest time we could start all these operations, but we need to remember one thing, that it was mentioned that once we start a operation, we can't wait. Like once we start executing ith operation for all the wizards, then we have to execute all of the operations sequentially, and we can't wait. But here we could see that we started here at 5, we started here at 30, we started here at 40, we started here at 60, so it won't work like this. So we have to do one thing. Now we know that this is the time that it took us to complete all the operations to complete first operation for all the wizards. It took us 64 units of time. Now we know that how much time did it took us to complete first operation for the third wizard. It was 1 into 4, so it took us 4 units of time. So it took us 4 units of time to complete first operation for the third wizard. So it means that we should have completed this task at time 60, because we have to perform it continuous. So this task has to be performed at time 60. Now we know that how much time did it took us to complete first operation for the second wizard, and it took us like 2 units of time. So this task has to be completed 2 units before 60, which is 60 minus 2, which is 58. Now similarly, we know that it took us 1 into 5, which is 5. So task 1 for wizard 0 has to end at time 53. So now we have constructed this array which tells us how much, what was the time we executed, we were done with the ith operation for the ith operation for all of the wizards. So this will help us to execute our next task, which is second task for all the wizards. So let's see how we coded this. So we need to maintain this array, how much time it took us to complete operation for the previous task. Also we need to know what was the time we completed execution of the ith wizard to predict, to say how much time it would take us to complete I plus 1 wizard. Okay, so let's start with the execution. So this is the previous array. I initialized it with 0 because we started with time 0, so there was no initial condition that we have to start at this time, so I just initialized it with 0. Now we start for each operation. So there are m operations, let's say. So we started with 0, and for the 0th operation we started from wizard 0 to all the wizards. So if it's the first wizard, then there is no previous wizard, so we could start with just previous of I, means at what time we ended it, like we ended it at time 5. So I could just add previous of I is equal to product of these two plus previous of I. But if we are at index greater than 0, then we have to also check what was the time we completed ith task for the previous wizard. Also, what was the time we completed the same task, what was the time we completed the previous task for the same wizard. So previous of I and previous of I minus 1. So the previous of I is what it is storing for the previous task, what was the time it took for the ith wizard to complete this, and previous of I minus 1 is the time it took for the I minus 1 wizard to complete this task, and max of this plus s of I into m of j. So I think this was clear. Now we need to reassign these correct values to the previous, because we were just calculating it for the ith for the just the ith wizard, but the actual time could be different depending on the last previous of n minus 1. So we backtrack and update all the previous of I up to 0, and then just return previous of n minus 1. I guess I was able to explain this. Thank you.